Hello and welcome to third lecture. In previous lecture, we have seen that common operations which are done in data wrangling are handling missing values, converting data types, detecting outliers, and treating them, deduplicating, that is, detecting duplicate rows and removing them, identifying and removing single valued columns, and normalizing. So let us take each one by one. Handling missing values and conversion of data type. So I first create the data frame which I want to use as an example. So this is not part of some kind of solution. As I earlier also said that I just tell ChatGPT that please create this kind of some kind of sample data with these columns and these uh, product ID, sales price, date, and each column should be filled with this condition. So it will generate the data. So it is just a synthetic data, fake data. Yes, from fake data I remember that in previous case, if you have seen carefully, there was import numpy as np. Pandas was already imported in the previous cell random, and this library was imported from faker. Import faker, and if these fakers with small f, that is the library, that is not installed in your PC, then it will show that no module named a faker. Then you just write pip install faker, okay, and we create a faker object, initialize a faker object, and then we do the analysis. Okay, fine. Now here we come back to our handling missing value, and so this is just creating the data. So it's code I don't need to explain. We are just creating the data with some columns and satisfying a certain condition. Fine. So this is that column. We just have to bother that it should satisfy our purpose. So handling missing values. So that means there should be at least some missing value. So I can see that none is seen in customer ID here, here, here. Now IDs are usually the primary column if I use the SQL terminology, and that means they are unique. They must be unique. Here they are not unique. That is another thing, and they must be present. They must not be null. So this null is should be treated. Similarly, somewhere in there must be some other nulls also. Say in sales. In sales, I don't find a null. Okay, I'm introducing nulls. So at present in sales column there are no null values, but I am choosing row number 5 to 10. So that is these 20, 82, 86, 74, 74, and 87. Okay, and 87 will not be included because perhaps 5 to 10 means only 5 rows, and that will be 10 up to 10 but not including 10. So take these many rows of which column, of sales column, and fill them with np.none. Remember, you don't write directly none, it will throw error because none is also a number, and therefore you have to use numpy library, and therefore earlier numpy should have been imported also. Okay, so if I now see my sales column, then I get that 1, 2, 3, 4, 5, and 6. So 10 is also included, 5 to 10. Okay, so that was my mistake. Sorry for that. Now then, these values are none. Now I have to treat them because the sales are missing, and suppose that sales itself is something very important. So I am not happy with these missing values. Now I want to put some values instead of that sale. What value can I put? Then it is an integer, or that is a numeric variable. So I have a choice. Either I can put mean sales or I can put median sales. As such, median is a better choice. But here, as an example, we are filling up with mean. Okay. So df sales is equal to df sales dot fill na. This is the function which fills na. Okay. Where you want, I mean, what do you want to, by which value you want to fill na? Then df sales dot mean. That means from all these values of sales, find their mean value. So this much says find the mean sales from these values. Obviously at that time none will be excluded. Okay. Then this says fill na with that mean value, and this says in which column you have to fill na. So then you have to fill na in this sales column. That means in itself. Now as such, this much only finishes the operation. This much, but the problem with that is that will not be copied in the sales column, or that will not bring a permanent change. What I'm saying is something like this. So if I do this, and if I again print df sales, then I am again saying my none. So what is happening? Is my operation failing? No, my operation looks correct. That take sales column, find the mean of all the sales, and fill the na in the sales column. Df sales dot fill na means in the sales column, fill the na with those mean value. Then why they are not getting filled? The reason is that this temporarily only changes the whole thing, but you have to assign those changes back to the column. So this is called permanently modifying your column. Okay, so you have to remember that sometimes such a silly thing is cause of a lot of bug, because you will see when I did not write that, no error was thrown. So if error is thrown, it is actually a good sign, because based on error message you can do some correction. But if no error is thrown, then person may be confused that what is happening. But now if I have assigned this whole RHS, so how should you read this RHS? Take DF sales column, that means take this column, fill its NA with DF sales columns mean value. So fill the NA with mean value of all these observations. Okay. And at that time, if I write now, if I see, then those NA, wherever the none were there, they are replaced by one particular value here. That is the mean value. Now, as I said, better method would have been median. So I can write here median instead of mean. DF cells dot, and as I said, you can put the tab character here. I think it is not coming because otherwise all available functions would also come. But it is very easy. Instead of mean, you just write median. Now here, if I try to do this, it will not do anything, because now there are no NAs. Okay, I have filled already by mean. So what I have to do is I have to do this step once again. Okay, that means I will introduce some NA, and this time I introduce supposing some different numbers, maybe 0 to, or maybe okay 0 colon 5, and these are, so now 0 colon 5 are having none. Now I am using the same, that fill DF sales columns NAs by using that column's median value. Why this? Okay, I think this should be up. Okay, now yes. So this is my original column, and now I am saying that take DF sales column, fill its NA non-values with median values. Okay, so these top 5 rows, that will be filled with median values. Okay, and here I think it is a normal distribution, so even the median has come out to be the same as the mean, but every time it is not necessary. Remember that. Okay. Now convert the price to integer. So data type of price is float, but I can convert it into integer. Suppose I don't care about so much of accuracy, and particularly 5 digits, 6 digits after the decimal point. So as I start building the model and everything, the calculation will become very lengthy and resource intensive. So I am interested in a high performance model. So there I just write df price as type int. As type int means convert its type from float to int, and then I again print, and this time you can see that print df, and if I see the d type of that is one more cell, let me add. Okay, but this is not converted into integers, it is still floating point number. Maybe I think df sales type of that. Okay, it is panda series, so that is not much useful. So I think I will have to make some better modification. Okay, I think the mistake perhaps was, I think I was checking the sales column. So otherwise this code was correct. The DF price original data frame was this, and the price is floating point number. But I don't want my price to be so accurate, 6 digits after the decimal. So I decided that I will convert them into integer. And the code which was there, DF price is equal to DF price as type int. But then I printed DF. I said earlier that sales remains floating point number, but sales will remain because I'm not converting sales, I'm converting price. So I included still one more column as a diagnostic purpose, that let me only print price column, then let me print entire data frame, and then let me also print the data type of that price column. Okay, in between, for clarity, I can introduce maybe something like this, so that results do not mix up with each other. Okay, so this now I think it is correct. Yes. So price is converted into integer. Then this is the entire data frame. Yes, in entire data frame also price is converted into integer. I think I was watching cells. That was the problem. And even the type of the data frame is also int 32. Okay. So that is the way to do it. So that means it was correct way. Okay, fine. Now here I was seeing the type of that sales. That was the problem. I should write type of price. Okay. So it is series because it is seeing the type of that entire data structure. Now if I see dot d type, then that will show me the type of what is contents of that data structure. So price itself, column itself is a series, panda series, but this is the data type of contents of that pager series. Fine, so that way also it is correct. Now, uh, this is the explanation, but that I have already given to you. So we learned how to handle missing values and how to handle how to change the data type. Okay. Now s type dot int can be here s type int is written. Instead, you can also write s type float or s type. Maybe sometimes it is int 32, but you don't want that much precision. Then you can write int 16, 16-bit format of integers. Just saves a lot of memory and more importantly, a lot of processing time. But that all things come when first you design your model and then optimizing for performance. Okay. Now, methods for imputing the missing value. I just showed two methods. That is, one method was substituting by mean and another is substituting by median. The question is what to do about the missing values in a, here all are numeric column only, so there is nothing much one can do. But if there is some categorical column, say gender, male, female, etc., but there may be missing value in one or two rows, then you use mode or mode. There is no such word mode in many libraries, so there is another word most frequent, but you know that ultimately both means the same. So either you use that column name dot mean or you use that column name dot median for numeric column, and or you use that column name dot the mode or the most frequent, depending upon which library you are using for non-imputation. This process of replacing the none, I will clear all output because I want to keep the context. So clear output of all cells. Okay. So this process of replacing the none values by some other values, that is itself called non-imputation. Now, or handling missing values. Now, this much knowledge is very basic elementary knowledge. That arithmetic or numeric columns are there, then choose median or mean, and numeric categorical column are there, then use mode or most frequent. Every time things are not that simple. For example, I was reading one research paper about what are different techniques for imputation of missing values, and I found this excellent diagram. Though I have already written that this is enough, whatever we learned that is enough for our course, but there are actually many values, some many methods. Some methods we will learn, but not all. Some are actually at the only PhD level or I mean research level. But you can see one is, if sometimes we just simply delete the row containing missing value. Sometimes we impute the row. Now, as you impute, there are statistical imputation methods or imputation based on machine learning algorithm. So that means you use some machine learning algorithm to impute the missing value. Now here statistical imputation method can be mean, regression, multiple, hot deck. We have not learned anything apart from mean. Okay. Then imputation, KNN, this we are going to learn, imputation based on machine learning. Then SOM, so SOM, then ANN, then artificial neural network, MLP, that is another way of, it is somewhat similar to another technique of machine learning, and multitask networks. So you can use this, okay. And alternatively, you can use model-based procedures, and their maximum likelihood, this we are going to learn in much detail. KNN we will learn, okay. Then Gaussian mixture model we will learn. Then here machine learning methods for handling missing data. So there actually these and these look same. Ensemble methods, fuzzy method, SVM, support vector machine, so that we will learn. Decision tree, that we will learn. Ensemble methods also will learn, but not all. Okay, so all these methods, if we try to learn for missing value imputation, and all are not required also, because some of these methods are very popular and very accurate. KNN, Gaussian mixture method, then ensemble based method. So they are enough to handle any type of data set. But this fellow did research on only imputing the missing values, so you can find this. Okay. Then the question is how to choose the appropriate method for handling missing value. For that, this diagram is there. Now, this diagram is a good diagram, and I say that one should at least have some idea about that. So, first you ask question: is the data roughly linear? Then use linear regression based model. So, like here, regression imputation. Okay. If it is yes, then use linear regression based model. If answer comes out to be no, my data is not linear, then is there any other trend? Maybe not linear, but maybe sine function or cosine function. Then replace missing value with the one before. So in that kind of case, you have to choose the previous value. That is, if missing value is in the row number 999, then you put what value was there in 998. if there was some trend, it may not be exactly linear trend, but at least some kind of trend going upwards, maybe like a stock market going upwards, then put the missing value just before. Then if there is no such trend, that is linear also not there and no other trend, no, then points missing completely at random. So that means ask yourself another question that okay, there is no trend, but are the points missing completely at random? If you get the answer that yes, they are, that means scan your entire data set. And now again, there are ways of scanning. You can plot a diagram which displays the missing value by white lines and the rest of the rows by red or blue, any color that you choose. So you can see that your lines are distributed according to some pattern or they are just randomly distributed. Okay. Then if there is random distribution, answer comes out to be yes, then use pairwise or list-wise deletion. Perhaps somewhere here, deletion, yeah, deletion of data instance. So, but in deletion also you have to do it systematically, not just delete. Okay, then if there is if suppose there is no linear trend, no other trend, not randomly missing value, then if ask yourself next question that are there only few missing values? If the answer comes out to be yes, then ask yourself another question that is your data set sample large enough? If that answer also comes out to be yes, then fill the missing values with zeros. Now zero will not make any difference or simply ignore them. Ignore means simply delete those rows. But provided your missing values are very few and your sample is large enough. Now these few and large are very subjective words. So is there any rule? Then normally the rule is that if there are less than 10% of the missing value and if any of these techniques fail, then you can finally, as a last resort, simply delete those rows. So if there are 1000 rows in your data set and there are maybe 80, so that is 8%. Okay, so then 8% are missing, rows contain some missing value in some columns, then you simply delete those rows. Okay, but if here large enough sample, that answer comes out to be no. Okay, so only a few missing value, that is right, that there are 8 missing value, but suppose your sample size is only maybe 40. Now out of 40, if you delete 8 missing values, that is you are deleting the 1/5 or 20% of missing value, so that is not acceptable. No, then are the point critical or vital? Then you have to examine each of that observation which is containing the missing value and think that whether that point is that means other columns, whether they contain some critical or vital value. For example, if it is cancer detection data set, now as such also, if you have a sample of maybe 40 patients, then out of them it is possible that 39 do not have cancer, but you are interested in that patient's data who has the cancer. Now if by chance for that patient's data there comes one column which is having missing value, then what will you do? If you delete that, then the only row which had the cancer patient data, you are deleting it. Then how will you detect cancer using that? How you build a model which to detect the cancer using that type of data? So that is a critical point. If answer is no, then impute or delete. But if answer is yes, then is power a priority? Power means predictive power. So there are certain models which are having high predictive power. So if that power is if the point are critical and predictive power is priority, then use more powerful methods like KNN or multiple imputation EM algorithm. So this KNN, if you see here, we had listed it as one of the method, is very powerful method and usually preferred method for putting the missing values, imputing the missing values. This EM algorithm is also another such method. And suppose here you get answer that are points critical, that we have done, large enough sample, that also we have done. Okay. Now imputation can also be done in this case. If points are critical, then either mean, median or weight of the complete process. Okay. So this is the whole flowchart of how to logically think. And please keep this flowchart in your mind because it is very difficult to remember all the strategies. Again, this is the thing which cannot be automated because the automation algorithm usually will not bother to think about all this. Okay. Now in next lecture we will do other. First lecture was how to handle missing value and how to change the data type. Data type was simple: column name, say df in square bracket, price in inverted comma, column name must be in inverted comma quotation, and then you write dot as type int. So that will convert the price column into int. But now we will do outlier detection and removal. Okay, but that is next lecture. Thank you for